Most of the time when we look at the world, we assume what we see is what is true. We trust our intuition. We trust our senses. We trust what feels obvious. But history shows something different. Again and again, humans have confidently believed things that turned out to be completely wrong. And yet, we never stopped learning. We never stopped questioning. We never stopped searching for better explanations. There is a simple reason for that we discovered a way to correct ourselves, a way to escape the limits of intuition and see reality more clearly, a way to replace guesswork with evidence and assumptions with understanding. This is the scientific method, the quiet framework behind every breakthrough you have ever heard of. It is not complicated. It is not mystical. It is simply a way of thinking that allows us to turn confusion into clarity. Today, we are going to walk through this method, step by step, not as a formula, but as a story. The story of how humans learn to ask better questions, to test their ideas, and to update their beliefs when the world surprised them. Let's begin. There is a quiet, powerful idea that changed the world. It didn't arrive with fireworks or lightning or a sudden revelation. It was built slowly from doubt, from curiosity, from people brave enough to say 3 simple words, "I don't know." This idea is called the scientific method. And once you understand it, not as a formula, not as something trapped in laboratories or textbooks, but as a simple way of thinking, you begin to see why science became humanity's most reliable tool for understanding reality. You begin to see why we stopped believing Earth was the center of the universe, why we stopped trusting superstition, why our lives, our medicine, our knowledge, and our entire worldview changed forever. But the scientific method is not complicated. In fact, it's beautifully simple. Today, we're going to walk through it step by step, slowly, clearly, intuitively. No jargon, no equations, just stories and clarity. Let's begin with a simple truth. Humans are often wrong. And I don't mean occasionally wrong. I mean profoundly, confidently, consistently wrong. For thousands of years, we believed lightning was thrown by gods. We believed disease came from bad air. We believed the sun revolved around the earth because that's what it looked like. And once we believed something, we clung to it tightly. We defended it. We repeated it. We passed it on. Humans love stories. But science demands something deeper than stories. It demands evidence. The scientific method was invented because our instincts are unreliable. Our senses can be fooled. Our memories can be distorted. Our beliefs can be biased. And without a disciplined way to question ourselves, we get stuck believing things simply because they feel true. So let's walk through the scientific method as it truly is a loop, a cycle, a way of thinking that helps us go from confusion to clarity. Step 1, ask a good question. This sounds simple, but it's everything. Every discovery you've ever heard of gravity, evolution, electricity vaccines, planets, atoms, began not with answers, but with curiosity. Why do apples fall downward? Why does the sun rise in the east? Why do some people get sick and others don't? Why do plants lean toward the light? A good question is honest. It admits uncertainty. It opens the door to discovery. It accepts humbly, "I don't know, but I want to." Step 2, form a hypothesis. A hypothesis is not a belief. It's a guess, but an educated one, a temporary explanation. It's saying, maybe this is why it happens, while knowing full well it might be wrong. If you notice plants turning toward light, your hypothesis might be that heat makes them bend. If you notice people sneezing around pollen, your hypothesis might be that pollen triggers an immune response. A hypothesis is simply the first draft of an explanation. And like any first draft, it's expected to be imperfect. Step 3, test with an experiment. This is where science becomes powerful. Because instead of trusting intuition, we test reality. Imagine placing one plant in sunlight and another under a lamp with heat but no light. Do they move the same way? Imagine testing how pollen affects someone by isolating variables one by one. An experiment is a controlled question aimed directly at nature. Not what do I think, but what actually happens. Step 4, observe and collect data. This step is more important than it seems, because without data, your conclusions are just guesses. Science is built on measurement, on writing things down, not trusting your memory, not relying on how things seem, but on what actually occurred. How far did the plant bend? How long did it take? What were the temperatures? How many times did the reaction repeat? Careful observation turns experiments into evidence. Step 5. Analyze your results. This is where honesty is required. Does the data support your hypothesis, or does it contradict it? If your hypothesis was wrong, perfect. That's what science is for. If it was right, great, but you still need to test again. Science does not seek to protect your ego. It seeks to reveal the truth, even if the truth is uncomfortable. Step 6, draw a conclusion. And here's the part that surprises most people. Conclusions in science are always provisional. They are best explanations so far, not absolute truths. If new evidence appears, the conclusion must change. This is why science progresses. Not because it is always right, but because it is willing to admit when it's wrong. Step 7, share the results. This is the final and often most misunderstood part of the scientific method. Science is not a private activity, it's a public one. Knowledge grows when we share it, challenge it, repeat it, and test it in new ways. The power of science comes not from one experiment, but from thousands of experiments pointing in the same direction. If a result cannot be repeated by others, it's not science. It's an accident. Now, instead of keeping these steps abstract, let's look at how they've shaped real discoveries. Hundreds of years ago, Galileo dropped 2 different weights from the Leaning Tower of Pisa to test whether heavier objects fall faster. Everyone at the time believed they did. Aristotle said so. Common sense said so. But Galileo asked a different question. And gravity revealed its truth. Pasteur questioned whether invisible germs could cause disease, a laughable idea to people who believed illness came from mysterious vapors. But through careful experiments, he proved that life doesn't appear spontaneously. It grows from life. Einstein questioned Newton's ideas of space and time, something almost unthinkable at the time. And through thought experiments, he reshaped physics forever. Each of these discoveries began with curiosity, followed by hypotheses, experiments, data, and conclusions that changed the world. But the scientific method is not only for scientists. It's for anyone seeking clarity. Because the scientific method helps us avoid common thinking traps. Confirmation bias, seeking only the evidence that agrees with us. Overconfidence, assuming our first guess must be correct. Anecdotal reasoning, believing a story instead of studying the pattern. Emotion-based conclusions, trusting feelings over facts. The scientific method forces us to ask, what does the evidence say? Not what do I want the evidence to say? Now, here's the twist, the part most people overlook. The scientific method is not merely a process. It is a philosophy. It is a mindset of humility, a willingness to update beliefs, a discipline of questioning assumptions, a commitment to letting reality, not preference, decide what is true. To think scientifically is not to memorize facts. It is to be open to correction. It is to say, I believe this for now, but I am willing to change my mind. And that is rare. That is powerful. That is what makes science different from opinion. Let's condense this mindset into a simple checklist. Ask, predict, test, measure, update. 5 simple words. But together, they form the backbone of every discovery humanity has ever made. The scientific method gave us vaccines, electricity, antibiotics, computers, telescopes, airplanes, and the food we eat. It gave us the ability to see beyond superstition, beyond illusion, beyond our own mental biases. The world is not what it appears to be. It is deeper, stranger, more beautiful than our senses alone can detect. The scientific method does not tell us what to think. It teaches us how to think. And once you see the world through its lens, curious, skeptical, humble, and open, you begin to understand reality, not as you imagine it, but as it truly is. Script ends. The scientific method is often presented as a checklist, a process, or a set of rigid steps. But in reality, it is something far more human. It is the courage to question what you think you know. It is the discipline to test your ideas honestly. It is the humility to admit when the evidence leads somewhere unexpected. And it is the curiosity to keep exploring, even when the answers are uncertain. Science advances not because it is always right, but because it is always willing to be corrected. And when you begin to think this way, when you adopt the mindset of asking, testing, measuring, and updating, you start seeing the world differently. You become less certain, but more accurate. Less rigid, but more wise. Less attached to opinions, and more committed to truth. If this episode helped you understand the scientific method in a clearer, more intuitive way, consider joining me for the next one. We explore ideas that sharpen your thinking and reveal the hidden structures behind how the world really works. Until then, remember, the goal is not to be right. The goal is to become right over time through evidence. That is the heart of science,